All right, in Calculus, Chapter 4, Lesson 3, the definite integrals today. And area under the curves using familiar geometry shapes. We'll be doing that as well. And evaluate a definite integral. All right, it says evaluate the definite integral, and we're integrating from -2 to 1 for the function 2x dx. All right, y'all, when we integrated, ignore those two numbers on there for right now, the 1 and the -2. So we're going to ignore these two numbers for a minute. When we integrate the function 2x dx, remember this was x to the 1. When you integrate, it was the reverse of the derivative. So we want to add 1 to the exponent and divide by your new exponent. So that would become 2x squared divided by the 2. So these 2's reduce. Notice the numbers that were here. I now write them at the end with this bracket. Now, what this tells me to do then is to plug in the top number first. So that would be 1 squared. And then minus when I plug in the bottom number. So I'm going to plug in the top number minus the bottom number. So 1 minus 4, and that answer is going to be -3. Now we're going to talk about this graph a little bit here. If I was to look at the area of this triangle right here, I just want what's from the line. I kind of ignoring the blue, just like what the purple part is. The base of this triangle is 1, and this height is 2. So the area of this would be 1/2 of 1 times 2, which happens to be 1. All right, let's take a look at this triangle right here. Okay, I'm talking about from the line. So this length is 2. This is 1, 2, 3, 4 for a height. If you took 2 times 4, that's 8, and half of that is 4. And it is below the x-axis. Now, if I was just asking for the area, this would actually be a +4. But because it was for an integral, if it's below the axis, it's represented by a negative. And that's where that -4 came from. And 1 minus 4 would be -3. So I wanted to give you a little geometry perspective on this as well. So it says the definite integral is the area of a region. So if I'm wanting the area of this curve from the x equals a to x equals b, then as long as the curve is like always above the x-axis, I just integrate from a to b. Now, if the curve ends up dropping down below the x-axis at some point, then we would have to integrate, say, maybe from a to b and then from b to c, because the integral from b to c would be a negative value, and areas are always positive. So just kind of keep that in mind. All right, so it wants us to find the area of the region bounded by the graph of 4x minus x squared and the x-axis. That's all I know. I have nothing else written here. So I need to figure out where does that graph cross the x-axis. I need to set the equation equal to 0 to do that. So setting the equation equal to 0 would give me x equals 0 and x equals 4. So it crosses at 0 and 4. It is a parabola that opens down. Boom. So I want this area in here. That means I need to integrate from 0 to 4 of this function. That's all it's telling me to do. So again, like I said, it's telling me to integrate from 0 to 4, left to right, like you read a book, of the function 4x minus x squared. This is x to the 1. So add 1 to that exponent, it's 2, and you divide by the new 2. So 4 divided by 2 gave me that 2. Then add 1 to that, that's 3, and divide by the new 3. And then remember, after you integrate, you do the brackets, plug in the top number minus the bottom number, and the numbers go out here now. Now I plug in 4 minus when I plug in 0. And my answer is 32/3. Okay. There's also buttons on the graphing calculator to show you the integral of this. Go ahead and have me show you that in class. I'm not really quite sure if my calculator, let me see here, if we can pick them up. Yeah, it wouldn't be too bad. So let me go ahead and go to my y equals. I'm going to type in the function real quick. Y'all do the same. So 4x minus x squared. Okay. I am going to go to a standard window. In case your pictures are messed up, I'm just going to do a standard window. So I just graph the function 4x minus x squared. Now I want that area between x is 0 and x is 4. So I'm going to take my actually I'm going to go and do it on here. I can go to second calculate right here above the word trace where my finger's at. Do y'all see that number 7? That's the symbol we're talking about today, isn't it? The integral symbol. So I'm going to tell it to integrate. The lower bound is 0, enter. My upper bound was 4, enter. And it shaded it, and it even gave me the answer of 10.66667. Ooh, look at that. We had 32/3. 32/3 is 3 goes into 32, 10, with 2/3 left over. And we had 10.66666 for that answer. Okay, so that's one way to do it. Another way to do it on your calculator would also be just to go to the word math, and number 9 down here So under math, number 9 is the integral. I can now tell if the integral there of 0, up arrow, give it 4. Inside, give it the function 4x minus x squared. Outside with respect to x, and push enter. And I also got the answer, the same thing. And then, and then I could hit math fraction at that point, and now we have it right. So it is important to know how to use your graphing utilities for this as well, as also knowing how to do it by hand. It'll be on a no calculator test for you on the final exam and for chapter 4. So make sure you know how to do this without the calculator. All right, sketch the region corresponding to each one and then evaluate it using just geometry. This time it doesn't want me to use any calculus. So the first one is the line y equals 4, but only from x equals 1 to 3. See, here's the line y equals 4, but only from x equals 1 to 3. Well, that makes the graph of a rectangle, hopefully you're saying. So this would be 2 times 4, and that answer would be 8. All right, so this one is the integral from 0 to 3 of the function y equals x plus 2. So start with x equals 0. Plug in 0, that would give you 2. Plug in 3, that would give me 3, 5. And if you look at it sideways, kind of tilt your head, take your head, the top of your head to the left, and you can see a trapezoid. Okay, that trapezoid has a height of 3. This base is 2, and this base is 5. The area of a trapezoid is 1/2 the height, 3, times the sum of the bases, which was 7, so 21/2. C. That would be the graph of, if you're thinking about y equals the square root of 4 minus x squared, you would square both sides. That would give you y squared equals 4 minus x squared. Move the x squared over, and that would be a circle. But it's only the positive square root, so it's only the top half of a circle. Now, this circle has a radius of 2, but I only want half of the area, so I want 1/2 of pi r squared. So 1/2 of pi r squared. And therefore, my answer would be 2 pi. So again, this part of the lesson just wants you to use the geometry to actually get your area of the shapes. So I want you to think about this one for a minute. If I was to integrate from a to a of a function, why is that always 0? See, if I integrate it, and then after I integrate, remember, I'm going to plug in the top number minus when I plug in the bottom number. Well, if I plug in a and then minus when I plug in a again, wouldn't that always be 0? Okay? And in this case, if I integrate and plug in a minus when I plug in b, well, what if I flipped it around? What if I plugged in the b then a? See, then that would be the negative of the answer. So again, if you have a, b, and you integrate and you flip it, it's just going to be the opposite sign. If you integrate from a to a, it will always equal 0. So it says find the value of the integral from pi to pi of sine of x dx. Wait a minute. If I integrated it, I'm going to plug in pi minus plug in pi. Well, I'm plugging pi into the same thing in both of them. So therefore, that would be 0. If I was to integrate, given the integral from 3 to 0 for x plus 2 is 21/2. What if I had to find the integral from 0 to 3? Wait a minute, that's the reverse of it. Same function. So again, if it's the reverse of it, this one is if I plugged in 0 minus 3 gave me that answer. Well, I'm just doing the opposite. I'm going to plug in 3 minus the 0. Well, therefore, then it would be the opposite of that, which would be negative 21/2. So kind of pay attention sometimes. If these are the same, it's going to be 0. If these numbers reverse from a given to what you have to find, then it would be the opposite of that answer. If they ask you to integrate with an absolute value, please look at the graph of it first, and then go ahead and calculate this using the geometry area for triangles. So if I have to integrate from -1 for the absolute value of x, so here's the graph absolute value of x. I want from -1 to 1. Y'all, this is a base of 1 and a height of 1. So this area of this piece would be 1/2 of 1 times 1. So that area is 1/2. That area is 1/2. Therefore, that final answer would actually just be 1. So please, anytime you have absolute, go ahead and look at the graph of it. Where's the V breaking? And again, take the area of the triangles. And these two do not always have to be equal. So be careful of that. Once we need to evaluate this, so I'm going to integrate. We're going to add 1 to the exponent and divide. So that would be 3 divided by the 3 here, x to the third over 3. That was x to the 1, add 1, so that'd be 2. When you divide by the 2, that became 4. This was 3x to the 0, add 1 to it, it's x. Now, y'all, we're going to plug in the 3 and then minus when we plug in the 1. So we plug in all the 3's, minus when we plug in all the 1's. And the reason we don't write the plus c on these, you guys, is if I have a plus c here and then I have minus a plus c over here, it's going to go away. So that's why we don't have the plus C's on these, in case you were wondering. All right, you evaluate each one and you get an answer of 4/3. It's very important here that you do know how to use the calculator to check if this is correct, but remember your test was without a calculator. Please make sure you can do these in your homework without the calculator because you're not given a calculator for the test on this. So this one says write the integral to represent it. See, my x's are starting at what number and going to what number? That's the first thing you want to ask yourself. They start at -3 and they stop at 2 for this function. So the integral would be from -3 to 2 of the function, and then this was with respect to x, because we're moving along the x-axis. Notice this time my function is in terms of y. So then I don't want to know where the x's are moving from. I want to know where the y's are moving from. These y's this time are moving from 0 to 2. So the integral would be from 0 to 2 of your function in terms of y. So notice I do the function was y cubed in terms of the y. So that part of the homework is literally you are just writing the equation to represent the area with the integral sign. It says the graph F consists of line segments as shown below. Evaluate each definite, not indefinite, by using geometric formulas. So first I went from 0 to 1. If I integrate from 0 to 1, this is below the x-axis. This answer will be a negative value. It'll be negative of whatever that area is. This is 1 times 1. That's 1, half of that, so that first answer is -1/2. The next piece one's from 0 to 3. So we already have that piece as -1/2. Let's get from 1 to 3. See, from 1 to 3, this is a length of 2. This is a height of 2. 2 times 2 is 4, but half of that is 2. So this area is 2, but that was -1/2. You combine those together, and therefore that would be your integral from 0 to 3. The next one I went from 0 to 1, but it says then 3 times the function. Y'all, all you have to do is factor this 3 out to the front. So I want 3 times integral from 0 to 1. So I want 3 times that answer, so it's -3/2. So this time I went from 0 to 3, which was this answer, times by -7, so that would be -21/2. So again, if you have a coefficient, just pull the coefficient out to the front and then times the answer from the 0 to 3. All right, if I went from 4 to 10, so here's x is 4, all the way here to x is 10. So first I need to look at 4 to 6. That's 2, that's 2. 2 times 2 is 4. Half of that, this little piece right here is going to be a 2. Now I need to go from 6 to 10. The length of that base is 1, 2, 3, 4. This height is 2. 4 times 2 is 8. Half of that's 4. So this piece at the bottom is represented with a -4. Then we have the coefficient of -5 afterwards to deal with. So first this little area here was 2. This area was 4, but it's below the axis, so it's a -4. That becomes -2 times that coefficient, and my answer is 10. So what if we needed from 3 to 11? So from 3 to 11, we just found this piece here, right there was 2. This piece, length here is 1, this is 2, so that's another 2. So 2 plus 2 there is 4. We found that to be -4, so it's like those two actually could zero out. So then this area is 1 times 1, so that's 1, but a half of it, so that's going to be 1/2 times that 4, the answer would be 2. So again, this little piece here is 2, this little piece area is 2, this area was 4, but it's below, so it's a -4. The area is 4, but the value of the integral from here to here is -4 because it's below the axis. And that one is 1/2. So once you simplify that, you get a half of 4 and your answer is 2. So find the area between the curve and the x-axis from x equals -2 to 4 for the function x squared minus 1. So y'all, x squared minus 1 would be a parabola shifted down 1, but I want from x is -2 to x equals 4. So here's x is -2 to x equals 4. So I want the area from -2 to -1 right here. It's on the top. Now notice I had to write minus from -1 to 1 because see this would be on the bottom, which is a negative value, but I want the area, so I need it to be positive. So that's why I had to do minus the -1 to 1 so that this right here become a positive value. Then I want to add the integral from 1 to 4. All right, and once you integrate each of those and add that together, you would get 19 and 1/3. And if I would need you to please try to do that problem, make sure you understand that. This is one I might possibly, I haven't decided yet, I might do just like a little small bit with the graphing calculator, and I might allow this one to be with the graphing calculator. Because I do want you guys to get the concept that the area, I want this value, the integral, this value, and then this value, because that's negative. You have to take the opposite of it and then add all those together. All right, that ends lesson 4.3. I hope you guys have a great night. We'll see you tomorrow.